Okay, in this video, we're going to focus on using life cycle cost accounting in new building design process and why it's very important for us. So first, why is life cycle cost accounting so important? Well, life cycle cost accounting, or LCCA, assesses the total cost of ownership. It takes into account not just the purchase cost, but also the expenses that might accrue over time, like maintenance costs, staffing, replacement. This is an alternative to focus on lowest cost, which may be cheaper at first, but more expensive over time. This is important for us because we're not just designing a building within the capital budget, but we need to live with these buildings. As universities, we won't be outsourcing over time. We'll be living in these buildings for conceivably the next 50, 60, 100 years. So we need to be able to get these things right. It also is very important for us to be looking at these tools in terms of our carbon accounting as well, because a bad decision at the very beginning, where we don't take into account the LCCA, means that we could be paying extra energy and in fact be accruing extra carbon dioxide emissions into the future with really very low ability for us to change that. So LCCA is especially useful in the design process, and especially when we're examining different options. So here's a very simple example. We just want to look at, let's say we have measure A and measure B. Let's say these are single pane windows versus double pane windows. And of course, measure B is going to be more expensive. If we're just simply trying to fit this within the capital budget, then of course, measure A is clearly the winner. The other one is 10% more expensive. That's more money that we would have to pay. But if we actually look at it in terms of how much will this cost us over time, we might see that measure A, while less expensive at the beginning, is going to cost us a lot more, perhaps even an extra 15%. So when you add that together, then that means that option B, or measure B in this case, is the better option over the long run. It's important too because these additional costs quite often are resulting in utilities. So something that's going to cost a lot more over time probably has an energy penalty that we'll have to spend. So that's where the greenhouse gas emissions will come from. We want to eliminate those. So the building related cost that we need to account for usually fall into the following categories. First is the initial cost, right? So that's the purchase. Of course, we know what that is. That's just our first cost. But we also have to include fuel costs, in our case, probably electricity. We need to include the operation, maintenance, and repairs. Those could be very costly over time if we pick the wrong option. Replacement cost, how much will it be when this option comes to the end of its useful life and then we have to replace it? And how long will it take while before we have to replace it? Some options might last for 5 years, some might last for 10 years. That's actually a very important consideration. And then the residual value. Now, that's a little bit more difficult for us here in Hong Kong, but is there some kind of a resale or salvage value or for this material? Or are there disposal costs? And we really need to think about that as well. For example, we have carpets that we know will have to be replaced at some point. And at this time, there's really no recycling options. So with the waste charging scheme, we have to pay for all of those to go to the landfill. If there's any finance charges or loan interest payments, that doesn't really apply to us at the university, but those would also be included. And then any kind of non-monetary benefits or costs. And so we might look at would one make us look better? Does one help us with the recruitment of our staff or students? Does one give us some bragging rights, for example? It's hard to put money on that, but we try to as we can. So here is the formula. The life cycle cost equals the the present value in dollars of our investment plus the replacement cost over time. And then we can subtract the residual value. That is, if we can get some kind of a salvage or resale. We must include the present value of energy cost and the present value of water cost, and then the non-fuel operating. So that would be, do we need to hire some new staff to be able to deal with this piece of equipment or this appliance? And then are there any other costs? Now, for us, we like to put all of this into a 25-year time frame. Now, you could do it in many different ways, but 25 years is generally a good time frame for us to evaluate. That's a considerable amount of time. There are some pieces of equipment that actually last longer than 25 years. Obviously, there are some that last less than 25 years. If it lasts less than 25 years, then we have to add the replacement value in. In other words, if it has to be replaced at 10 years, then there'll be two replacement costs over our 25-year time frame. So let's take an example of flooring. Now, let's imagine that the design team is looking at two different options. One is commercial carpeting, and the other one is polished concrete. We know that the polished concrete is definitely more expensive in terms of first cost, but how would it compare over time? So we would do the same thing. We'd look at the initial cost and we'd see that one is much more expensive than the other. In this case, there's no fuel cost, but there will definitely be some operations, maintenance, and repair cost. In fact, carpets, as I just mentioned, they just simply don't last as long as polished concrete. Polished concrete could last the entire lifespan of the building, as long as it's maintained in a good way. So concrete would not have any replacement costs where the carpet would. The residual value, there really is no residual value, but carpet, when it has to be disposed of, will cost us money as it goes to the landfill. In our case, there's no finance charges or loan, but there may be some other non-monetary benefits or costs in terms that it's easier to maintain. Perhaps we don't have to train our cleaning staff to be able to do anything special. They just clean it just like it's a hard floor. Now, in this case, we would have to add both of those things up over time, and what we'd find is one is probably better than the other in terms of these costs. For us, we would also be including the cost of carbon, and we'll talk about that in a future video. But what we are doing is we're actually looking at the socialized cost of carbon, and we have to add that into this life cycle cost analysis because what we want to see is if one is more costly in terms of payments and also is one working against us in terms of carbon. So, in a following set of videos, we will examine some of these a little bit more in detail, and we'll have some spreadsheets that we've developed here at HKUST. These are free and they're available. We hope that you will take advantage of them. We've designed them for use by contractors and designers. Of course, you're welcome to use your own. Maybe you might like to just see what we do so that when you design your own, then we're all on the same page. But just keep in mind that the life cycle cost accounting is not just a request by HKUST. It is one of the most important tools we have for ensuring that we're making good decisions over time, and it really is one of the key components of our net zero action plan.